Imagine something so powerful that nothing can escape it. Not light, not matter, not even time itself. Something that warps the fabric of reality just by existing. I'm talking about black holes, the universe's ultimate predators. They're everywhere, they're invisible, and one is lurking at the center of our own galaxy right now. Let's explore. A black hole is what happens when you squeeze an enormous amount of mass into an incredibly tiny space. The gravity becomes so intense that nothing can escape, not even light, traveling at 670 million miles per hour. That's why they're black. No light can bounce back to show you what's there. They're invisible voids in space. Most black holes are born when massive stars die. When a star at least 20 times bigger than our sun runs out of fuel, it collapses in on itself. The outer layers explode as a supernova, but the core keeps collapsing. In less than a second, all that matter crushes down to a single point. Boom, black hole. The edge of a black hole is called the event horizon. Think of it as the point of no return. Cross it, and you're done. You could be the fastest spaceship ever built, traveling at the speed of light, and it wouldn't matter. Once you cross that line, you're going in. Even light itself gets trapped. That's what makes it an event horizon. No event inside can ever affect the outside. At the center of every black hole is something called the singularity. All that mass, all that matter, compressed into an infinitely small point with infinite density. Our math literally breaks down here. The laws of physics as we know them simply stop working. What's actually at the center? Honestly, nobody knows. It might be the universe's biggest mystery. Here's a terrifying word: spaghettification. It's what would happen to you if you fell into a black hole. The gravity at your feet would be so much stronger than at your head that you'd be stretched like spaghetti. You'd be pulled thinner and thinner until you're just a stream of atoms being sucked into oblivion. Scientists actually use this word. It's real. Black holes don't just warp space, they warp time. The closer you get to a black hole, the slower time moves for you compared to everyone else. If you orbited just outside a black hole for what felt like an hour, years might pass for the rest of the universe. This isn't science fiction. It's Einstein's relativity, and it's been proven. If you fell into a supermassive black hole, you wouldn't feel the event horizon pass. But looking back, you'd see the entire future history of the universe play out in fast forward. Stars would be born and die. Galaxies would collide. And as you fell deeper, the universe behind you would compress into a ring of light. Your last view would be literally cosmic. Black holes come in different sizes. Stellar black holes are small, only a few times the mass of our sun. Intermediate black holes are thousands of solar masses. And then there are supermassive black holes, millions or billions of solar masses. These monsters sit at the centers of galaxies. And get this, we have one. At the center of our Milky Way galaxy sits Sagittarius A star, a supermassive black hole, 4 million times the mass of our sun. It's 26,000 light years away, so don't worry, we're safe. Stars orbit around it at incredible speeds. We actually have photos of it now, taken by linking telescopes across the entire Earth. In 2019, scientists released the first ever image of a black hole. It's in a galaxy called M87, and it's 6.5 billion times the mass of our sun. The bright ring is superheated matter swirling around at nearly the speed of light. The dark center is the shadow of the event horizon. We photographed the unphotographable. Stephen Hawking discovered something amazing. Black holes aren't completely black. They slowly leak energy through something called Hawking radiation. Over incredibly long time periods, trillions and trillions of years, black holes actually evaporate. The smaller the black hole, the faster it evaporates. Even the mightiest black holes will eventually fade away. Here's a cosmic chicken and egg question. Almost every large galaxy has a supermassive black hole at its center. Did the black holes create the galaxies? Or did the galaxies create the black holes? Scientists are still figuring this out, but it seems like they grow together. The black hole and its galaxy are partners in crime. When supermassive black holes actively feed on matter, they create quasars, the brightest objects in the universe. The matter falling in heats up to billions of degrees and blasts out jets of energy visible from billions of light years away. A single quasar can outshine an entire galaxy containing hundreds of billions of stars. Black holes create the ultimate light show. When two black holes collide and merge, they create ripples in space-time called gravitational waves. In 2015, we detected these waves for the first time using incredibly sensitive instruments. The collision released more energy than all the stars in the observable universe combined. And we felt it here on Earth, a billion light years away. Some scientists theorize that black holes might be connected to wormholes, tunnels through space-time that could link distant parts of the universe, maybe even different universes. We have no evidence this is true, and even if it were, surviving the journey seems impossible. But the math says it might be possible. Maybe black holes are doorways to somewhere else. Black holes create a huge problem in physics. Information should never be destroyed, but black holes seem to destroy everything that falls in. Where does the information go? This information paradox has puzzled physicists for decades. Some think information is stored on the event horizon. Others think it escapes through Hawking radiation. Nobody knows for sure. Some theories suggest that tiny micro-black holes might have been created in the early universe. These would be smaller than atoms, but as heavy as mountains. Scientists have tried to create them in particle accelerators, like the Large Hadron Collider. Don't worry, even if we made one, it would evaporate instantly through Hawking radiation. Probably, in the far, far future, black holes will be the last things left in the universe. All stars will have died. All matter will have decayed. Only black holes will remain, slowly evaporating over unimaginable timescales. The last black hole will evaporate in about 10 to the power of 100 years. Then, nothing. Black holes will witness the end of everything. Black holes remind us how strange and wonderful the universe is. Objects that break physics, warp time, and will outlast everything else in existence. They're terrifying and beautiful, and they're real right now, scattered across the cosmos. Next time you look at the night sky, remember, black holes are out there, silently bending reality. Thanks for watching.